Welcome back to video number 2 on multi-step equations. This video is going to focus on multi-step equations or solving equations that have fractions and decimals, okay? So this one is about fractions and decimals. What do you do? What can you do with fractions and decimals to make the process of solving the equation much easier? Well, what we're going to do is I'm going to show you a process called clearing the fractions. Okay, clearing the fractions, and all this is it involves two things. It involves the multiplication property of equality, which says that I'm allowed to multiply both sides of the equation by something, and the equation stays in balance. But the second part is, well, what exactly am I going to multiply both sides of the equation by? And the answer to that is the common denominator. All right, so if we're looking at an equation with fractions, we're going to use the multiplication property of equality and the common denominator. And with these two things, you'll see that we can do something called clear the fractions, and that's going to make our lives so much easier. Let me show you what this might look like. Okay, so here's an example. I'll change my color. So if I had the equation 2b over 5 plus 3b over 4 equals 3, you're probably asking yourself, oh my goodness, there's fractions in here. How do I combine these together? Well, okay, both of the terms on the left side do have just a b. Technically, they are like terms and can be combined together. We would have to treat the coefficients as fractions, like 2/5 and 3/4. And then we'd have to use our rules for fractions, adding fractions. We'd have to find a common denominator and all this kind of stuff and rewrite them. Rather than doing all of that, let's just use our multiplication property of equality and a common denominator to help us solve a problem. And that way, it doesn't matter what fractions you're talking about. It could be super, super complicated fractions. We can use this technique and simplify things a lot. So the first thing I'm going to do is I'm going to look at the denominators, and I'm going to decide, all right, well, what are the common denominator? What is the common denominator? 5 and 4. An easy way to find a common denominator would just be to multiply the two numbers together, right? So 5 times 4 is 20. 20 is a common denominator. That may or may not be the least common denominator, but you know what? In this case, it doesn't matter if you use the least common denominator. All you need is a common denominator to do this technique. So we know the common denominator, or a common denominator, is 20. What I'm going to do is I'm going to multiply both sides of this equation by 20, okay? So, whoops, you know what? I'll do it this way. All right, so I multiplied both sides of the equation by 20. And what happens, remember, as long as I multiply the same thing on both sides, my equation stays in balance. So on the left side, I have a little distribution to do, right? Because I need to multiply two terms by 20. But on the left side, or on the right side, excuse me, all I have to do is multiply 3 times 20. So what does it look like on the left side if I multiply both terms by 20? Well, I've got 20 times 2b over 5 plus 20 times 3b over 4. Right? See what I did there? I turned 20 into 20 over 1 because I know I'm going to have to multiply it by a fraction. And for me, visually, it's nicer to see a fraction times a fraction. It just makes things a little bit more easier to recognize in my brain. And on the left side, I have 3 times 20, which is 60. All right, if you remember, when you multiply fractions, all you do is multiply across the tops and across the bottoms. So what would that look like if I simplified this? Well, 20 times 2b, so I'm over here, 20 times 2b is 40b, and 1 times 5 is 5. And then on the next one, I have 20 times 3b, which is 60b, and 1 times 4, 1 times 4 is 4, equals 60. Now, because I multiplied it by a common denominator, you might notice that the fraction that I'm left with can be simplified into regular old integers. No more fractions, right? 40 divided by 5 is 8. So 40b divided by 5 is 8b. Do you remember when we did dividing terms by a constant? This is exactly the same thing. And then plus 60 divided by 4 is 15. So this is 15b. Look what I did. I cleared all the fractions. That makes life so much easier. Now I can combine my like terms, 8b plus 15b, which is 23b equals 60. And I can now solve for b by dividing both sides by 23. b equals, oh man, boy, it would be nice if this were a nice number, but you know what? Since our original problem had fractions in it, why don't we just leave it as a fraction, 60 over 23? I'm okay with that if you are. Since our original problem was made up of fractions, let's just keep the answer as a fraction. That's really called keeping the integrity of the problem. And we do that a lot in math. So, for example, if we had a problem with decimals in it, then we would keep our answer in decimal form. And if we had we had equations that had fractions, we would keep our answers in fractional form. So we just used a technique called clearing the fractions in order to make solving an equation like this a lot simpler. Now, we can do something similar to problems that have decimals, right? But this time, instead of multiplying by a common denominator, so let's talk about decimals for a second. Let me just write down an example. All right, so if I had 0.5x minus 2.325x equals 3.95. If I had a problem like this, in this day and age, this is not that difficult if you have a calculator, right? It's not that difficult at all. Oh, I'm sorry. I just noticed something. I want to get rid of that x there. I don't want that x there. With a calculator, this is not a problem at all. But I'm going to show you a way that you can do this without a calculator to make it a little bit easier. So remember when we were solving ones with fractions, we multiplied by a common denominator? Well, when we're working with decimals, what we want to do is multiply each of them, or both sides, by a factor of 10, okay? So remember, a factor of 10 would be like 10, 100, 1,000, 10,000, 100,000, right? We're going to multiply by some factor of 10. When you're working with decimals, multiplying by a factor of 10 is actually quite easy because all it means is that you're moving the decimal point to the right a certain number of places, right? So, for example, if you're multiplying by 100, because 100 has 2 zeros, you're moving the decimal point 2 places to the right. If you're multiplying by, let's say, 1,000, the number 1,000 has 3 zeros, so you're going to move the decimal point 3 places to the right. I guess the question then is, well, what could we multiply? What power of 10 or factor of 10 can we multiply every term in this equation by in order to clear every single decimal point in it? If you look closely, this term right here has the most number of decimal places, right? It has 3 decimal places. So in order to eliminate the decimal places here, I would need to move my decimal point 3 places to the right. 3 places to the right. And so I would have to multiply every term by 1,000 in order to clear all the decimal places in that term. And that's how I figure out how many places I'm going to move the decimal point over in each of the terms. So I'm going to go ahead and I'm going to multiply both sides of this equation by 1,000. All right, so multiply it by 1,000. And what that does is it moves my decimal point over in each of the terms 3 places to the right. So when I multiply 0.5 by 1,000, I get 500. And when I multiply 2.325 by 1,000, I get 2,325. And lastly, when I multiply 3.95 by 1,000, I get 3,950. Now, you'll notice what I have essentially done is I've eliminated all the decimal places in this problem. And I can just follow through and solve it through my normal procedure. So if I would add 2,325 to both sides, 2,325 to both sides, that'll eliminate those, and I'll get 500x equals 6275. And then lastly, divide by 500, I get x equals. Now, what kind of number do you think I should get for an answer? In this problem, should I leave my answer as a fraction, or should I leave my answer as a decimal? Because my problem started with decimals, I'm going to leave my answer as a decimal. So I'm going to go on my calculator, and I'm going to do 6,275 divided by 500, and it turns out that x is equal to 12.55. 12.55 is my solution to this problem. So this video was about looking at specific types of multi-step equations that involve fractions and decimals. And I showed you how to clear the fractions and clear the decimals so that solving them becomes a lot easier. All right, remember, we employed two things. The multiplication property of equality, which says, as long as we multiply both sides of my equation by the same thing, it maintains a balance. But also thinking about what I can multiply both sides by in order to eliminate the fractions or eliminate the decimals. In the case of fractions, it was multiplying both sides by a common denominator. And in the case of decimals, it was multiplying each side by some factor of 10, which eliminates all the decimals in every single term. Go ahead and practice these. And if you